We are Team 2, the Balls of Fury, and this is our robot. Our team consists of Allegra, Antonino, Douglas, and Marta. Our robot is 12 inches wide and long and 11 inches high, fitting within the box of justice. We decided that we should focus on launching balls over the wall rather than trying to fit them through the holes in the wall, while also remaining on the bottom level of the arena to maximize time spent collecting balls. We used the scoop to lift the balls onto a funneled ramp that feeds the balls to our launching bat, which hits the balls over the wall. We used a two-wheel drive with 2 DC motors, since we only needed to get the robot down the ramp but had no plans of climbing back up. The wheels have a diameter of 4.5 inches and were casted out of EcoFlex 0050 silicone. This ensured that the wheels were durable and allowed them to interface efficiently with the arena surface. For the scoop, we designed it in SolidWorks and 3D printed it since we wanted it as light as possible. We used a continuous servo motor instead of a 90-degree one in order to have the full range of the scoop motion needed. We designed the arm so that it would be attached at a 45-degree angle to the scoop. We attached the end of the arm directly to the servo, avoiding any additional small, complicated mechanisms we would otherwise need. According to our initial calculations, the continuous servo motor would provide enough torque to be able to lift the scoop. For our launching mechanism, while initially using a flipper with only one side, we noticed that some balls would fall through and not be hit over, so we switched to a two-sided one. For the final competition, we also printed an extra flipper, since this is the most high-impact piece of our robot and has the potential to break. Additionally, we decided it would be a good idea to spring pin the flipper to the shaft in order to ensure that the flipper won't move. We wanted the flipper to have a high speed, so after some initial calculations, we determined the gear ratio we would need and had to modify the gearbox by switching the 2 gears in order to obtain that ratio. The slide acted as a funnel to direct the balls to the ideal position over the flipper, which was determined after many trial runs, so we designed this last. During seeding, we were able to get 20 ping pong balls over to the other side, and our team is confident that with more practice driving, we will do even better in the final competition.